Hello, this video covers the topic of angle pairs in geometry. There are several different angle pairs and they all have their own properties which you need to know. So the first one here you see is the vertical angles. That would be talking about like angle 1 and angle 3. Those are both considered an angle pair, like it's one pair. 2 and 4 would also be another pair. So just because the word vertical is there, it doesn't necessarily mean like it needs to go up and down. It just means that they're across from each other when you have two lines or segments that intersect. So 1 and 3 is an angle pair, 2 and 4 is an angle pair. And the whole idea here for the property is that it's kind of like scissors, right? If you were to take these two lines and kind of move them up and down and back and forth or whatever, it would act like scissors, where the angle measure on the left would always equal the angle measure on the right. It doesn't matter how these lines are orientated. And the angle measure on the top would always equal the bottom. So let's say this was 100 degrees at top. Sorry, this not the best tool in the world, but there you go. If let's say that was 100 degrees, then angle 4 would also be 100 degrees. No matter what angle 2 is, angle 4 would measure the same. You can also, like, you do have lines here, right? So if you know one angle, you could use the idea of a straight line, that there's 180 degrees in a straight line, which you could figure out angle 1 is 80. And of course, if angle 1 is 80, then angle 3 would be 80, right? So pretty simple concept. Just the idea of vertical angles are angles that are across from each other when two lines intersect. Now this is that linear pair we were talking about. Most people know this one. You know, in a straight line, there's 180 degrees. So if you have two angles that are next to each other like this that form a straight line, then you can call that a linear pair. So angle 5 and angle 6 together would equal 180 degrees total. And so if angle 5 was 110 degrees, then angle 6 would have to be 70, and vice versa, right? Okay, so that's just linear pair. To make a linear pair, they do need to be adjacent to each other. They need to be attached and actually form a straight line on one of their sides together, right? And you can see they share a common side. Like angle 5, one of the sides of angle 5 is this ray, and one of the sides of angle 6 is also that ray. So they share a common ray, right? Now, two different names, two more angle pair names that we need to know is complementary, and then on the next slide here I have supplementary. Complementary is where they add up to 90. So if you have two adjacent angles here, that could make a complementary angles where you have 90 degrees. Maybe this one's like 30 and angle 2 is maybe 60, right? If that was true, then of course I would have complementary angles because they add up to 90 degrees, complementary. Now for complementary and supplementary, they do not have to be adjacent. They could be like this orientation here, angle 3 and angle 4, or they could be anywhere. So any two angles that add up to 90 degrees, we can call them complementary. They add up to 90 degrees. Same thing, supplementary. Now, obviously, supplementary angles could be the linear pair type. So linear pair, a linear pair is supplementary. They are supplementary angles. But just because you say supplementary doesn't mean they have to be a linear pair. They could be non-adjacent. So any two angles that add up to 180 degrees would be supplementary. So there's a couple practice problems. Now, when I look at this one, my first thought might be like, oh, I have vertical angles, like the left and the right have to be equal to each other. This one and this one, which is true, but the problem is this is x and this is y. That's not going to help you solve it. So to solve this, I'd probably use the idea of a linear pair first, because here I have an x and down here I have an x. So let's put those two together and end up having a linear pair, which we know is supplementary, because they add up to 180 degrees. So I can take the 3x plus 5 and add that to the x plus 15. We're going to add those two together and equal to 180. So I'll just add the like terms together. 3x plus x is my 4x. This is not the best drawing tool in the world, but here we go. Then we got 5 plus 15 is 20. So I'm just adding those two expressions together. But I know they're a linear pair, so they're supplementary, and they equal 180. So 4x plus 20 equals 180. I'll subtract 20 to get 160. and then divide by 4 to get my 40. So x should be 40. This is not degrees, this is just what x is. You can go back up to these problems to figure out what the actual angles are. So 3 times 40 would be 120 plus the 5, so this is 125. And if I put 40 in here, I'm going to get 55. I'm just going to double check myself to make sure that these two add up to 180. 125 plus 55, yeah, that's like 170 plus another 10, that's 180. Yeah, so it does work. So I know that y plus 20, since it's vertical to this one, would also equal 55. So this has to be 55 total, so I know that y has to be 35. And I'm done. Last problem. So they're telling us that we have two angles that are complementary. A and B are complementary. So if they're complementary, I know they add up to make 90 degrees. Oh, and by the way, just a little trick for you. If you forget which one's complementary and which one's supplementary, complementary has a C in it, right? It starts with a C, and that's 90. If you take another 90, that would be 180, right? So let's take another C and just write it backwards, and now I have an S. So two C's make an S, so two complementaries make a supplementary, which 90 plus 90 is 180. So you can always remember that complementary is the one that's 90 and supplementary is the one that's 180 because it takes two complementaries to make a supplementary. I know, a little cheesy, but maybe it'll help her remember. Okay, so this is complementary. We'll want to add these up. 2x plus 25 plus 6x minus 31. Add them all up, and that should equal 90 degrees. Yeah. Not the best tool. All right, so let's combine like terms. I get 8x, and I have 25 minus 31 is negative 6, equals 90. Ugh, hard to make nines in this tool. All right, and then I'm going to add 6 to get 96, and then divide it by 8. (96) divided by 8. So isn't that 12? 12, yes. So that's 80 plus 16, that's 96. Yes, so 12 is our answer. And that's it. That's the end of this lesson. That's just you'll see them in different kind of forms, and you'll see pictures where you have a whole bunch of different combinations. You'll have complementary angles, like a 90-degree angle somewhere, mixed with vertical angles, mixed with, like, you'll have lines going in different directions, and you need to be able to look at that diagram and say, oh, there's my vertical angles, there's some complementary angles, there's a linear pair, right? And we also, when we start getting into proofs in the next unit, you're going to notice that we need these ideas of complementary and supplementary and vertical angles in order to complete our proofs. So you should know these angle pairs, like inside and out, forwards and backwards. So, all right. Thank you very much.